let's get started on today's content. So that should have me up on the screen with the presentation. Yeah, if you see any issues with that, please do let me know. But until we see that, I'm going to continue on. So today we are going to be talking about a lot of stuff to do with variables. So we talked a bit about variables last time, and I went over them in better detail in the video that was posted on our channel yesterday. So if you were confused by any of the stuff that we talked about last time, especially with regards to variables, I do recommend that you check that out. It's partway through the video. We might be able to find a time stamp for that at some point, but we don't have that available right now. But yeah, I prefer the way that I presented it in the video to the way that I presented it to you guys last time around. So my apologies to you all for that. But what we're going to talk about today is we're going to talk about doing things with variables. So again, we touched on arithmetic operators last time. We're going to talk about them a bit more today, and then we're going to talk about how do we start to combine variables using arithmetic operators. How do we start to make some more complicated expressions? Then we're going to talk about a really interesting and very, very useful topic, which is updating variables using themselves. Then we're going to talk about variable scope, which is a sort of nebulous topic. That one has a lot of potential for it to be confusing, so we're going to try and make sure that we get that as clear as possible for everybody. And all throughout, we're going to have exercises, and at the very end, we have some cool examples of stuff that you can do pretty much only using what we've talked about up to now. So let's continue on to arithmetic operators. So again, these by and large behave pretty much the same way that you expect arithmetic operators to behave normally. So addition adds two inputs, subtraction subtracts one from the other, multiplication multiplies, division divides. It's all fairly straightforward. The only thing you might not be familiar with is the modulus operator. And the way the modulus operator works is it's effectively the remainder. So you'll probably recall that in elementary school or in grade school, when you learned division, you didn't learn to divide with decimal places. You learned to do integer division. So something like 15 divided by 4 wouldn't be 3.75. What it would be is 3 with remainder 3, right? Because 4 times 3 is 12, so you have a remainder of 3. So the modulus operator gives you that remainder. You guys probably won't end up needing to use it. There's a lot of circumstances where it can come in handy, but they tend to be more complicated sorts of circumstances. So generally, if you find that you want something to behave kind of like it loops around back to the start, that's about when you would want modulus. And we recommend, if you're in that sort of circumstance, that you talk to your mentors, because they'll be able to help you through that and explain why it works in your particular context. So, combining variables. So having just the variables on their own, like we did last time, is useful, as we saw, because it lets you use the same value in multiple places without having to type it over and over again. But what's really useful about it is being able to use these values together in various sorts of ways. So you can see I'm actually just going to hide my video here real quick. That button. There we go. So you can see that we have two values, and then we're trying to print what their sum is, and then what their product is. And then we do an interesting thing where we assign the value to another variable based on the values of already existing variables. Right? So I'm going to switch over to the code window. So in here, if we do our standard kind of structure with def setup, we say a equals 20 and b equals 30, and then we print a plus b. We expect that what this will give us is the result 50. If we instead print a times b, where times is indicated using the asterisk, which is the special symbol associated with the 8 key on your keyboard. So Shift 8 is how you type asterisk for those of you unfamiliar with it. You will probably have seen multiplication mostly as an X in your classes and in your math classes up to now and in school. It's generally used, we generally use a dot or a star or something like that in kind of higher level math and in programming stuff, because very often we want to use X to mean the letter X, as in your position, or some other unknown value. So having X meaning this multiplication operation then gets a bit confusing. So we instead use a different symbol. And we expect the result of this to be 6,000, which is 20 times 30. And now if we say D is equal to A plus B times 30, what we expect is that A plus B is 50, and then when we multiply that by 30, what we should get is 1,500. And so we can then print D, and if we run this, and what we see in the console is 50 followed by 600, not 6,000. Haha. Yes. I can program, but occasionally I can't do basic arithmetic, so my apologies to you all for my failure there. Yeah, 20 times 30 is 600. And so we see exactly what we expect, which is 50 followed by 600 followed by 1,500. So the really interesting thing here is this assigning D using the values from A and B, right? Oops, I need to switch us back to the presentation. So where this gets really interesting is where we start to use the value of the variable to set the value of the variable. Now that's kind of a confusing sentence. So I'm going to break it down a little bit more. So the equal sign in most basic math it describes a relationship between the two sides, right? So in math, if you say x equals 5, that's saying that the value of x is 5. But in programming, equals has a slightly different meaning. So here what it means is it's assignment. So when we say x equals 5, that isn't a statement about whether or not x is 5. What it is it is defining x to be 5. Right? As we have on the slide, we say height equals 170. Right? So the left-hand side, which needs to be just a variable, is set to whatever the right-hand side is. Okay? So for that first line, height gets the value 170. But a couple lines down, what you should be able to see, and I'm also just going to quickly do that so that's not in our way. So next line down, we say height equals height plus 5. And that would be a nonsense statement in basic arithmetic, because there's no value for height that makes that statement true. But that's not what we're doing. We're saying we want the value of height now to be whatever the value of height was previously plus 5. So it's increasing the value by 5. I'm going to pop us back over to the coding window just so that we can see that more directly. So we say, we'll call it h because height is a special variable. So we'll say h is 170. We're going to print h. And then we're going to say h is equal to h plus 5. And we're going to print h again. So we expect our first print h to print 170 because that's the value we just set it to. And then this one will print 175 because it takes whatever the old value was and adds 5 to it. And if we run this, then we will see our previous 50, 600, 1500, followed by 170 and 175, exactly as we expect. So this is a really, really useful thing to have, is these variables that can update themselves, and whose value we can use in making the new value, right? So if we want to move something, this is generally what we want to do. We want to take whatever its previous value was and change it somehow. So, yeah. So that's pretty much the primary reason we want to have this, is so that when we are trying to draw stuff, or we're trying to move stuff, or we're trying to have anything that changes over time, we have this ability to take whatever the previous value was and then update it. So I'm going to swap back over to the presentation. So the question here, which is worth Ignite points, so answer that in the Zoom chat, and we will see how it goes, is it okay to declare variables inside the draw function? As in, will this have the ellipse moving in the positive x direction? And I'll give you guys a couple of minutes to think about that and type up your answers in the chat. But the important thing is to consider why it might not work that way. Vertex Lord, who still has not changed their name, appears to have the correct answer. So every time the draw function runs, it will set x back to 10. Right? So every time it runs, whoops, sorry, my setup is confusing me. Every time this code runs, it'll set our background, then it will set x to 10, and then this symbol shouldn't be here. We're talking about that a little bit later, but this is effectively the same thing we're just doing. This is a shorthand for x equals x plus 1. So that will set x to then be 11, and then we'll draw our ellipse with that position x. So I'm actually just going to pop us back over to the code window here, and we will have a look at this directly. So let's say I'm going to clear out setup. We'll say size of 600. And then we're going to do def draw, which is again just our kind of structural component. We're going to type background 204, 204, 204. I'm just copying the same code from the slides. Okay. And then, sorry, also just dealing with some stuff. X equals 10. I'll say x equals x plus 1. Ellipse at x position of x, y position of 100, and width of 50, and height of 50. And when we run this, we see that the ellipse just stays fixed in place, right? Because every time this runs, it sets it back to 10 and then increments it by 1. So that doesn't work. But we also have a problem where it's not necessarily clear where we need these things to actually go. So I'm going to switch us back to the presentation again. So this is where we talk about variable scope. And again, as I mentioned earlier, variable scope has the potential to be a very confusing topic. So please do feel free to ask questions about this topic especially. But variable scope determines how long variables last for and what parts of the code can see them. So when we write code that's like our previous stuff, the value of x doesn't actually, it doesn't last past the end of draw. So we started it inside the indentation for draw, and so if we didn't actually have that line x equals 10, then we would have an error, which some other people noted. Yeah, because if we ran it again and we didn't have that line x equals 10, processing wouldn't know what we were talking about. It doesn't know what x is inherently. So we need to tell it what we're talking about when we talk about x. So when we want to have variables that we allow to change over time, that we allow to have different values through different iterations of the draw function, of the draw kind of loop, the draw block, we need to define them outside of draw and then tell processing where to go looking for it. Those variables we call global variables. Those are the ones that we define outside of setup and outside of draw, and they're accessible inside of setup and draw. So again, that has the potential to be very confusing when it's abstract. So we have an analogy that's hopefully helpful. So each of setup and draw is a bit like a house. variables can only talk to variables in the same house, and commands can only use variables in the same house, and only where they've already been kind of addressed. We already know who we're talking about. So, in order to talk to variables outside of the house or in the global scope, we need to effectively open up the window or the door of our house and call outside. And we do that using the keyword global. So I'm going to switch us back over to here. So if we want this to work, then the code that we need to write is something like x equals 10 here. So this sets up x as a global variable. We need to get rid of x equals 10 here. And we need to tell processing that inside draw, it needs to look globally for x. And we do that by typing global x. So it says look outside of draw to find this variable. And if we run this, we see that we get an ellipse slowly drifting across our sketch. It'll go off the side of the screen and continue off into infinity. So again, if you were confused by that, please do feel free to ask questions. That is one of the more confusing concepts, is variable scope. But we are going to move on from it now in the presentation. But again, if you have questions, ask, because we're going to start getting into examples and exercises soon. So, I thought we removed this example, but we'll go over it anyway. So we have our variable width height, and that describes the width and height of our square. So what this program is going to do is make a square that grows in size over time. So if we switch back over to the code window, let's actually just clear out our sketch totally. So we're going to make our global variable width height. And we're going to set that to 25. We have a So would it make a difference if we put the variable from inside def setup to just outside both def setup and def draw? So the code that I had written, actually, that line wasn't in setup. So remember, we only say that lines are in setup if they're indented. And you can see this line isn't indented. So this is actually outside of both of them. It comes after setup, and that's fine, but it's not in setup. But for clarity, we will move it above setup. Like that. So yeah, it doesn't really matter where those go. They can't go kind of in the middle of a block. So if I tried to do something like this wouldn't work because these two lines are indented, so they're in draw. Then this line isn't indented. So we're telling processing this line shouldn't be in draw. But then we're asking it to put these lines back in draw, and processing just gets very, very confused. So we can't do that, but anywhere that's not inside, between lines that we want to be inside draw or inside setup is pretty much fine. Excellent question. Yeah, okay. With that aside, I am now going to continue with this example. So width height equals 25. Say def setup size 600, 600. Whoops. Def draw. And then again, we want to be working with the variable width height. So we tell processing that's what we're wanting to do. We want it to look outside of draw for the variable width height. So we say global width height. Then we say width height is equal to width height plus 1. And then we will draw a rectangle whose top left corner is at 25, 25, and whose width and height are both the variable width height. This is a confusing example, which is why I thought we'd removed it, so my apologies, but I do want to go over everything that we have actually in the slides. And so you can see that we have this square which grows over time, in a very similar fashion to the way that our ellipse moved across the screen. So, switching back to our presentation, as I mentioned before, programmers tend to get lazy, so we like shorthands for things. So we have these two shorthands. We have plus equals, and we have minus equals. So the left-hand side is effectively just copied over to the right-hand side, and a plus is put between it and whatever is already on the right-hand side. Now that has a potential to be confusing, and we had a lot of people actually confused by what sort of things are allowed with this last time around, so I do just want to go over this a little bit more. So if we want, I'm just going to isolate this line as well. So when we have something that looks like this, where we have width height is equal to width height plus something, whatever that something is, we can instead write this as width height plus equals something. Whoops, plus equals something. So this directly translates to width height is equal to width height plus something. Okay? It's a little bit subtle, but what that effectively means for us is that we can make some more complicated expressions as well. It doesn't necessarily just need to be a number. You just need to be a little bit careful of how you're working with it. Oops, I don't actually want to delete that. So we'll say width height is width height plus equals 1. So the plus equals is referred to as the increment operator, and minus equals is the decrement operator. And the reasons why those are called that is mostly historical, but effectively that's just what it means is when we're increasing a variable by some amount, we're incrementing it by that amount. When we decrease it by some amount, we're decrementing it by that amount. And so in the same way that plus equals translates to a plus sign, minus equals translates to a minus sign. So if you're confused about that at all, please do feel free to ask your mentors, and you will have time for that right now, because we're getting into our first exercise for today. So we'll give you about 10 minutes for this. So this is the first exercise. This is on operators. What we would like you guys to do here is to create a variable, x position or x pos. I mean, you can follow the instructions, but what you're trying to do is draw a diagonal line of squares. So we're going to send you all into breakout rooms here momentarily. We'll call you back at 6:35. Sorry, actually, let me check a more accurate clock. Yeah, 6:35. And we will continue on. So I'm just going to briefly talk about the code that I wrote to demo this to the group I was talking to, just because there's the potential for confusion here again. So we're just going to briefly talk about the exercise. So I've done the full kind of diagonal thing. And what's really interesting about how this is set up is that what we have is these squares set up so that they're touching on diagonal corners. So maybe we don't want these in particular, we don't want these in this particular position, so what we can do is just change this x pos. What that will do is change just the kind of leftmost side. It'll also change our bottommost side, but not going to touch on that for the moment. But what that gives us is this ability to have these things that are always positioned the same relative to each other, which is often very useful. So we're going to continue on with the presentation. I moved my camera, but I will move that back, and we will continue on. So as we've mentioned a couple times, and I don't necessarily want to belabor the point, but it is important to note variables can vary, which is why they're called variables. We want them to change over time. We want them to take on different values because that's how we actually make use of them, is by having them do different things at different points in time. In this particular case, what we're actually interested in doing is using a variable to change another variable. So the little code snippet we have there sets up a variable called speed, and then what we do with that is that we increment our x position, or our x variable, using the value of speed. And so what that will do is if we have something like an ellipse moving across the screen or something along those lines, that will give us an ellipse that moves across the screen with some speed, and that we can change that speed as well, because we can let speed change over time. Something like that is adding gravity, right? So in real life, the longer something is falling for, the faster it falls. So the speed gets faster. I'm going to switch us back over to code again. And we're going to, oh, thank you for spotlighting that. So we're going to do an example with an ellipse. So we're going to set up a global variable because we want it to change over time. So we need it to persist outside of draw. So we're going to say y is equal to 0. And we're going to say speed is equal to 0. So we're starting with we're at the top of the screen and we have no initial speed moving downward. Then what we're going to do is inside draw, we're going to say global y and speed. If you have multiple variables that you want to use, then you can just put a comma between them when you're doing global. So we say global y and speed. So that says for both y and speed, look outside in the global scope. Then what we're going to say is y plus equals speed. So this is now adjusting y upwards, so meaning that the ellipse will move downwards because y is increasing, so our distance from the top is increasing, by whatever the current value of speed is. And then the interesting bit is we're going to say speed plus equals 1. And this is going to be very fast, but it should serve to show our, kind of give an example. So we're going to say ellipse, and we'll put that at x of 300, and y, and then we'll say a width and height of 50. And so if I run this, you see that the ball moves downward, but every frame it moves downward more. Right? Does that make sense? Yeah. So that's how we do stuff like acceleration in, sorry, my mic was in my way of seeing my computer. That's how we do stuff like acceleration in doing these drawings. And this is also very useful for stuff like physics simulations, which is something that a lot of people have expressed interest in doing in previous kind of sessions, is doing physics simulations, because they're good fun and they're an interesting challenge to try and get working right. I'm going to switch us back to the presentation again. And we can see that once again we have that same code that I just had. So we have here another code snippet that's, again, we're just kind of changing something over time to try and see how it behaves. So there's a couple of things in here that we haven't really talked about before, so we're going to talk about those briefly. Those are text size and text. So yeah, so text size and text. We'll talk about those. Oops. Making a grand old mess of things. So text size sets the size of your text, and it's very similar to fill in that it only changes the size of text that comes after it. It doesn't change anything that's already happened. Then text prints some text as in the same way that we print our ellipses and our rectangles to the sketch surface. So in this case, we have text hello at x and y. And so that wherever x and y currently are, that will draw those there. So I'm going to switch us back over to code. So we will start by saying x equals, let's say it's 0. Let's say y is also equal to 0. We'll say size is equal to, let's call this something a bit more descriptive. We'll say this is text size is equal to 15. Another thing to note is that variable names can't have spaces in them. So very often when we want to separate words, we'll do that in one of two ways. We'll either use an underscore, or we'll use a capital like that. But because processing has already used that for the command text size, I'm not going to do that here. I'm going to use the underscore. Then what we're going to do is in draw, we will say global x, y, and text size. Then we will tell processing to draw our text with our current size. Then we'll draw the text. Let's keep it simple. We'll just do hello at x and y. Text behaves like rect in that it describes the top left corner normally. Yeah, there's ways to change that, but I think it normally describes the top left corner. Then we're going to say x plus equals 3 and y plus equals 4, and we'll say text size plus equals, let's do 2. So what we should expect to see is text that is going to get larger and move across the screen down and to the right. And one thing that I forgot that I do want to put in is a background. So we'll put in background of 100, 100, 100. As a side note, any RGB colors that are all the same number, so 0, 0, 0, or 100, 100, 100, or 255, 255, 255, those are all going to be some kind of grayscale. And so you can see that we see pretty much what we expect. If we make this increase by something slightly smaller, so we'll only have it increased by 1, you see it doesn't grow quite as large, quite as fast. Oops, switch back to the presentation. Another thing that we can use these values that change over time is fading colors. Now this was one of the examples, and it showed up in some of the examples and exercises at the end of last session, and a bunch of people asked about that. So some of you will already know this, but what you can do is change the value for, say, green over time. So this would start with something that's not very green and then proceed to something that is green. Somebody has asked in the chat if there is a way to change the color of text. There is a way to do that. I think it is text. Whoops. I can't recall what it is. It's available on the reference, and I'm sure one of our mentors can go quickly look that up for me while I show this example. So I'm going to switch us back over. Richard has noted that changing text color should just use the same thing. So why don't we actually try doing that here? So we're going to make another global variable. We'll call this global variable green value. I'll start by setting it to 0. And then we need it to be a global variable. So we tell processing that it's global. And again, no matter how many I want, I can just separate them with commas. So in here, we're then going to do a fill of 150, green value, 150. And then we will increase green value by, say, 1.5 using the same example as in the slide set. So this is going to start with something that's only red and blue. Then it's going to add more and more green as it goes on until it ends up being mostly green. You see we start with purple, fade through a gray, and then to a green. If I make this move somewhat slower, so let's just have this increase by 1 each time, then we can see that it actually kind of gets stuck at light green. So any values larger than 255 will just effectively get rounded down by processing to 255. Okay. So we have our next exercise for today's session. We're going to go into our breakout rooms again, and we'll send us to those momentarily. Okay, looks like we have just about everybody back now, so we will continue on. We are pretty much done with our content for today, so we're going to go pretty much back into our breakout rooms so that you guys can all work on the exercises that we've talked about and on some of the examples that we're going to show in just a moment. Yeah, we don't really have any more content for today. We'll be a bit more heavy on content in the upcoming days, hopefully. And yeah, so let me again hide my camera. So these are some examples that we have. Sorry, that second one hasn't loaded. There we go. So that right one, what we would like to see is a kind of perfect loop. So when we are, this particular GIF has an imperfect loop where it kind of bounces in the middle. We would like to see it just oscillate up and down very smoothly. The example on the left, again, they don't need to be exact, but they should be approximately right. The one on the left is somewhat challenging, so I do wish you all the best of luck on trying to do that one. And then we have a couple more here. The one on the right is very, very complicated. That's number 4. If any of you can emulate it exactly, I will be very, very impressed. You can get pretty close with a lot of relatively simple things, but I believe on our channel somewhere we do have posted a video of me explaining how that particular sketch works, and all of the code for these examples will be made available eventually. So thank you all very much for coming. We're going to go back into breakout rooms, I think, for another 15 minutes for people to ask questions and work on examples and such. I believe that's the plan, yes? Richard has made an excellent observation in the chat that for examples 1 and 4, you need a lot of variables. That's very true. Yeah. They're good fun, and if you can figure them out, then you have a very, very good understanding of pretty much everything we've done. But if you can't, you shouldn't feel bad, because they were made by someone who is a little bit of a tryhard. I'm not going to name names or anything. Yeah. Thank you all very much for coming. We'll go back to breakout rooms, and I will talk to everybody else next week.